Hello, my DevNation friends. Welcome to the first Tech Talk of the year. And we're going to start the first Tech Talk of the year talking about super interesting subjects such as Quarkus, Cassandra, microservices. Well, can get much better than this. And for today's Tech Talk, I have a special guest, which is our friend Rags from DataStax. Hello, Rags.
Hey, Edson, thanks for having me. Glad to be part of the Tech Talk. I know that we are all kind of waiting to get out there and see each other in person, right? But I think we have a pretty good session planned for you, or at least I have. So we'll go from there. And with that, should I start, or do you have anything else to add from a housekeeping perspective, Edson?
No, I think like we're all set, all good to go. I just like to point out that you mentioned to me that you're in Boston, but I can see a pool in your background. So, is there where you want to be?
Yeah, I'd love to be. We don't know, but really, can't wait to go out and travel and be with the developers.
People,
Right,
yeah.
that's kind of where we are.
Warm weather, yeah, definitely.
Oh,
So,
warm weather, yes, for sure.
so let's
Exactly.
start. So today, live from Boston, Massachusetts, and Cary, North Carolina. Welcome to DevNation, and Rags, the stage is yours.
Thank you again, and thanks for having me. And good morning, good afternoon, good evening, wherever you are. It's great to be part of a global community. We do the developer workshops at DataStax pretty much every week, and we have a wide range of audience. A lot of people who are just kind of beginning, and some people who have kind of worked quite a bit. So what we tend to do is we try to get a pulse. And again, it's a little bit harder to do it virtually, but I think we're going to use Menti. We're going to try to use Menti today. And once I get an idea of who I'm talking to, I can tailor my demo a little bit better. So that's the goal. With that said, let me introduce myself first. My name is Raghavan Srinivas, but for whatever reason, people around the world have a tough time pronouncing my name, right? So I just go by Rags. Rags, not to riches, easiest way to remember me. Some of you might see me in earlier conferences or something. I usually wear a hat, the Indiana Jones hat. So next time you see me in a real conference, come by and say hi. But I think what I like about many of these workshops and kind of the live coding part of it is, as a mechanical engineer, the closest thing that I can see things move, especially in the software world, is code, right? So I like to see, get my hands dirty, and play around with code, and hopefully, I'm gonna fail a little bit, and that'll be kind of fun, right? To see people struggle a little bit, but that's kind of how we all, that's kind of how we go, right? So I love distributed systems. I really love to teach and communicate, and one of the biggest passions is the inner loop. And what I mean by the inner loop is exactly what Quarkus does: is to be able to do this over and over and over again, in the day. And if you can kind of get some productivity gains around that, it's going to help you a lot. So we'll talk about the inner loop, where you do the Quarkus colon dev, right? And then finally you put it into production, the lightweight CI/CD loop, as it's referred to. With Kubernetes and some of the other distributed systems, it's a lot easier, but it's still not there yet. Okay. So with that said, let's move on. Let's do a quick intro. And actually, I skipped Menti. I'm not quite sure. So let me go to the Menti slide, okay, and get some ideas of where you guys are from. Okay. So to go to Menti, use this code that is 67281372. Go to menti.com and use the code 67281372. Okay, let's see if this works. Always fun to see if it works. All right. It'll be great if you can confirm that you're getting it. Perfect. We have a few from Brazil already. Bongia. How do you,
Bom
I'm
dia.
trying. Okay, couple from Boston. We'll wait for a little bit, and
Mhm.
that's great. Few from Europe, a lot from Boston actually, or
Mhm.
North America anyway. Um, is that Cuba? The dot below?
Who knows? Or maybe Miami.
Could be my yeah. Uh, I think actually you were talking about weather, right? I'm planning a trip to Miami next week, so that should be fun.
Oh, awesome.
Somebody from Canada, nice. Chile, nice. Fantastic. This is really very, very cool to see a lot of people. Is that dot in the very top corner of Brazil? Is it Recife or something close by?
Could be Recife,
Yeah,
yeah, Salvador.
could be Salvador. Okay, yeah, yeah. All right. Global audience, thank you for responding. Let's move on to the next question. Have you been to any of our workshops before? Chances are, if you're like a seasoned programmer, it's probably a no. Um, but really, our goal is to up level. Oh, there's one person. Very cool. Thanks for joining this, and you can also tell your friends or chat and tell them how useful some of these workshops are. We pretty much start from scratch, and then you play around with the code in GitHub. You do it all yourself. Okay, it's pretty much self help, but we are around to guide you around and so on. And then there is a presentation and so on. Enough said about that. What's your experience with NoSQL databases? It could be anything really. It could be Cassandra, Mongo, and that's kind of what I was expecting as well. Never used it. I have some experience. Yeah, that's kind of what I was thinking as well. A lot. Oh, there's quite a few who are using. Okay, there are two people at least. Quite a few who have never used it. That makes sense. Okay. Very cool. I am a master. Got to watch out for the person. Yeah. That's cool. 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 All right. One final question, I believe, or maybe there are a couple more. What's your Java programming language experience? Just so that we are clear about this. Well, quite a few gurus. A lot. Nice. Nice. So I don't need to explain too much about Maven and all that. Okay. That is perfect. A lot. Perfect. Perfect. Yeah. Very cool. Very cool. Okay. That's kind of what I expected as well. So thank you very much. Thank you for participating. I think that's the last question, really. One final question, which is, have you used Quarkus before? Okay, that's kind of what I was expecting as well. Okay, some of you have never used Quarkus, or at least like more than 50% have not used Quarkus. Oh, it's getting better. It's getting close. It's time. Okay, yeah. Okay. So quite a few have not used Quarkus before, and I probably should have asked. Have you used Quarkus quite a bit or a little bit? Kind of in line with a similar question, but I think this gives me an idea. This is good enough. So let's get started with the presentation because I have quite a few slides to go through. All right, let me go back into presentation mode. And this is the agenda for today. We are almost through the intro, and today's challenge is to build a to-do app, which kind of looks like this. Okay, very straightforward. It has a UI, and essentially what you can do is you can drop items into the to-do and then tick them off, right? And you can clear them if you want, or just keep them around to feel satisfied that you are knocking off some of these to-dos. Okay, so this is the Menti part. I knew it was in there somewhere. But let's skip that. So let's talk about the NoSQL. For those of you who have never heard of this term, it basically was a name that was coined, to come up with some catchy hashtag. When there was a meetup in San Francisco, people were a little bit disillusioned about relational databases. And there were other databases which were kind of kicking around like Cassandra, Mongo, Couch, and so on. And they wanted a catchy term, and they just came up with, it's not SQL, so it's NoSQL, right? And sometimes referred to as not only SQL as well, but there are critical differences between relational database and NoSQL. Okay, and I'm going to keep this introduction pretty short. But the idea is that with NoSQL, it's really about commodity hardware and being able to scale. And if you think about some of the modern distributed systems today, like Kubernetes or even Istio, service meshes, and so on. The nice thing about many of these is it's able to horizontally scale. And one of the nice things about Cassandra, NoSQL, many of the NoSQL databases is that horizontal scaling is easy. You're able to do multi-cluster, multi-region, pretty straightforward. Okay, and you will see that in action today, hopefully. Okay. One of the big things about relational is that it has ACID transactions, which is the atomicity, consistency, isolation, durability. NoSQL, on the other hand, may not give you the guarantee. And there are different levels of consistency that we'll talk about in just a second. So you might have heard of this Brewer's conjecture or CAP theorem. And the CAP theorem basically states that, when you have a failure scenario in a typical distributed system, what happens is you have to pick two of the three. You cannot have all the three at the same time in failure scenarios. When everything is working perfectly, which is probably never, right, in a distributed system, you can have all three. But when a failure situation occurs, then you have to pick either of the, two of the three. So you have to sacrifice one of those, right, which is either the partition tolerance, the availability, or the consistency. Okay. And depending on which you pick and or which you sacrifice, right, there are different kinds of NoSQL databases as well. The taxonomy is kind of based on that. So here are some few examples of this. Cassandra is considered a AP database. But you can also kind of tune your consistency and make it more of a CP kind of system. We never really sacrifice partition tolerance. So what is Cassandra, what is Astra, and what is Cassandra? One of the big things about microservices is it comes in different shapes and forms, right? So you need to be able to kind of work with different platforms. And correspondingly, Cassandra, you can install it on-prem, on your own data center, or it's available in the cloud, which is what we see in Astra. Or, there is another form which is called Cassandra, which is a play on Kubernetes and Cassandra. And essentially what it is it's Cassandra on Kubernetes. And we'll see all of these in action today. Okay. So one of the nice things about, like I said, about Cassandra, even though it predates Kubernetes and maybe even predates the cloud, right? Because, this is 2009, 2008 we are talking about, right? It's really about horizontal scaling. There is really no single point of failure because what it does is it uses something called as a gossip protocol. And as long as, one node is able to talk to the other and build some consensus, it actually will be able to service the request. It may not be able to, because the data is distributed on multiple nodes. All of this is taken care of by the platform. The simplistic view of a NoSQL database is that, it's kind of a distributed hash table, if you will. Going by the Java analogy, right? It's distributed, but I don't know where it's distributed around the world. I don't care. And what happens if one node comes and goes? All of those is handled by the platform, right? Keeping track of the replication, keeping track of durability, resilience, and all that is the platform's responsibility. Making sure that there are no hot partitions, and we'll talk about partitions, where all of the data kind of goes into one node. It's all handled by the platform. It scales for writes and reads, and really application can contact any node. And as long as you're able to contact a node, you should be able to get your work done. So one of the key things about this is you have to parse partition, right? Can I do it myself? Of course I can, but it's really very, very hard to do that, right? And that's why you would rather let the platform kind of do this, and the platform kind of, like I said, handles all of this automatically for you. Uh, uh, in Cassandra, you can tune the consistency. There are a number of different quorums that you can set up, and you can see all that in action. Not all of them in action today, but at least you can see some of them in action today. One of the nice things about Cassandra, it's really used in many of the born in the cloud kind of companies, if you will. It's really at Apple scale. I've talked to some of my customers who basically say that they have never rebooted Cassandra in like 8 years or 10 years or something. I hope they're updating, but the kind of logos that you can see here gives you an idea of how critical this is. And there is a reason for this, right? Because it's really geographically distributed. It can be on multiple clouds. It doesn't matter whether you're, in fact, if you go into Astra today, Astra is, I'm kind of leading into that, is essentially our database as a service. You can have it on Azure or AWS or Google Cloud or so on, or install it on OpenShift as well on your enterprise or your own Kubernetes cluster. In fact, yesterday I think we had a workshop where we talked about how we can install Cassandra or Cassandra on OpenShift. But let's get back to Astra. Astra is basically a database as a service, multi-cloud, a multi-node cluster, and again, it's based on open source Apache Cassandra. One of the criticisms of Cassandra, and that point is rightly taken, or it's definitely relevant, is that even though Cassandra is cool and all that, it's very hard to install, very hard to maintain, and so on. AstraDB, we call it the serverless database, where you don't need to worry about the database at all. Is our in the cloud, Cassandra, if you will. So one of the cool things, and we do, so though I think two of you attended the workshop, that we provide you a $25 per month credit, and you don't need to put in your credit card. All that you need to put in is your email, and you should be able to get started. And actually, it does millions and millions of transactions, actually, even with the $25 month credit. So you can do some pretty significant things, and even handle some production loads. Why am I talking about my product? I'm not trying to sell any of this to you, but as a developer, it's pretty cool because, again, if you attend some of our workshops, or if you want to go and try this maybe later yourself, you can do that. No credit card required. But if you don't want to use the the database as a service, you can install it yourself. Okay, but yet kind of have some of the benefits, reap some of the benefits of what we have in Astra, because you may be able to guess that what we use under the covers in Astra is Kubernetes, actually. Okay, so that's how we kind of manage the whole thing. You don't need to worry about it, but if you want a little bit more control, you can install it on your own Kubernetes, and I will show an example of that today. But essentially, what you want to think about Cassandra is that it's Cassandra running on Kubernetes. Okay, and I'll not spend too much time on this. I have some workshops that kind of go through this. But essentially, what this does is it installs something called as a Cass operator, and the Cass operator, which is short for Cassandra, essentially takes care of a lot of these day two operations for you, including being able to do backup and restores, being able to do repairs, getting your metrics using Prometheus and Grafana, doing your ingress using Prefig, and so on and so forth. Okay, and it's a great platform to basically install microservices or to deploy your microservices. So with that said, let's come to Quarkus. I know this is a very quick introduction, but hopefully this kind of gives you an idea of what we're going to talk about, and sets up the stage for our live coding. Essentially, like I said, Inner Loop is really about developer productivity. Our developers used to wait 2 to 3 minutes to see their change. Quarkus took all that away. If you have not used Quarkus, I suggest I'll point you to a workshop where you can try that out yourself. Really cool. I love it because you can just do a Quarkus dev and change whatever you want, and it's automatically reflected, right? Uh, some especially Java programmers were always in envy about like Node.js and Python and some of the other platforms which used to provide that, but now with Quarkus you can do that. Okay, very cool. But it's still Java, right? All of you are Java programmers, so I don't even need to talk to you too much about that. In a typical Java framework, this is kind of how it works, right? You do some amount of things in build time, and then you do a whole lot of things in runtime, right? Is there any way to speed up our startup? Maybe even get rid of the VM. We love the Java VM, but is there any chance we can do that, right? And that's kind of what Quarkus does. Is there is only a little bit that needs to be done at runtime, and you'll see that in action today as well. I'm going to build a native image, and we'll see how that works today. So with that said, can't wait to jump into live coding, but a little bit about the microservices and the part that we're going to look into. Okay, like I said before, I kind of set the stage that we're going to do a very simple to-do application, right? And that's the goal for today. But let's take a brief tour into history, right? If you look at 90s, the monoliths were like, it's really about like, everything, user interface, the services, the data, everything was in one. And then you kind of separated them into front end, back end, and data layer, right? And then you gradually moved into services, service-oriented architecture. And now it's really about microservices, right? And microservices really, you can think of it as like, services calling each other. What was the one thing in 90s that pretty much changed the world? That was browsers, right? HTTP. And essentially what you do here with microservices is also very similar. HTTP is ubiquitous. It's there everywhere. It's not the only answer, but you leverage HTTP and you are able to connect these services together to be able to have a fairly sophisticated solution. I just put this out as an eye chart. it's from CNCF. The landscape is vast. Okay, this is cloud native compute foundation, right? And essentially they have a whole bunch of stuff. If you look at this, this service mesh itself, there are quite a few. There are a bunch on API gateways. We'll look at API gateways today if we can. Remote procedure call. We're gonna briefly address gRPC and so on and so forth. And then of course there is Kubernetes itself, right? So the point I'm trying to make here is that there are variety of different ways of kind of implementing your microservices. But to talk about what Martin Fowler said, there are some principles of microservices. Maybe not all of these are still relevant. Some of these have kind of evolved, so to say. Like for example, the smart endpoints and dumb pipes. That thing has changed now, and sometimes the pipes are intelligent as an Istio, where you can distribute the traffic based on on some kind of algorithm that you want. But the principles of microservices, a lot of them are still pretty relevant, right? Like it needs to be highly observable. You need to be able to isolate failure. You need to be able to deploy them independently, right? To be able to deploy them independently, you have to have a culture of automation. Now, can I connect services from one to another? And today, what we're going to do is we're going to leverage a backend that we haven't even built, but we're going to plug in that backend or the front end, the backend, and all the different combinations. Just to make sure that we can leverage others' work. And that's really what microservices is all about, right? Because it's a service and it does one thing and one thing well. Okay, enough said. What are the advantages? What are the disadvantages? Pretty straightforward, right? Reduced cost, reduced risk. It all depends, but still, the complexity definitely increases a lot. Definitely cultural changes, and sometimes it's a bigger run footprint, right? Number of different ways of implementing this. REST is probably the most prevalent. as long as you're able to decouple the client and the server, right? Or as long as you're able to decouple the different components, I think you can do it whether you want to do it in REST or whether you want to do it in gRPC or with Graph. There are a number of different options here, right? One of the cool things about REST is that it's really cool for CRUD-based operations. And what I mean by CRUD is create, read, update, delete, right? So, okay. gRPC, it does binary serialization. One of the criticisms of REST is that it uses a little bit more verbose protocol on the wire, and it may not be ideal for low latency operations, right? But with gRPC, which is Google RPC, it actually optimizes it a lot more. But there are, of course, there is no silver bullet. There is no discoverability. The serialization format is protobuf, so you'll have to kind of deal with that. And especially if you're doing observability and kind of troubleshooting, that may be something you need to pay attention to. One of the key things that neither REST nor neither REST nor gRPC does is is that it doesn't do discoverability well. So with GraphQL, you can get discoverability and some more. So what does Quarkus Cassandra extension do? Basically, it's a driver. It is a native Quarkus configuration. It provides session support, and we'll see all this in a second. It provides its own object mapper. And what do you mean by the object mapper? It's pretty obvious, right? Essentially, what it is it provides you a mapping between the database and the object, and we'll see what those are in a second. It supports support for mutiny types. I talk about, one of the things that Nicholas Wirth talked about is that programs is equal to algorithms plus data structures. Algorithms, Quarkus is great, reactive, and Cassandra is great, responsive, right? You can kind of put them together and you have a pretty powerful solution. It does native image support. It does its best effort, and there may be some edge cases where it may not work, but something that you may want to try, and at least in my case, in this particular example, you will see that it's working. Okay, and there is support for DataStack Astra. How do you use them is pretty straightforward. All that you do is you provide a connect bundle. I've already done this and I've already set this up. And then you provide a key space. Key space is simply a container for holding the data. And there are several different combinations of how you can do this. You can provide a username, password, and then the connect bundle, or you can provide a token, and there are several different ways of getting authenticated. Okay. There is, of course, the SQL session, which is really what basically you inject into your program, and then you have the DAO, which is the data access object. All of these, for those of you who've used Quarkus, it's probably familiar. But essentially, we have the data mapper as well, the object mapper, and then support for mutiny types. And essentially, you can see here, you have the path/product/ID, and that's kind of maps into a REST call. And then what you do is you find the product, and then essentially return the data. So let me see how I'm doing with respect to time. I do have a lot of time to do my live coding, and let me set this up. What it does essentially is that it lists all the tasks, and then obviously you can create a task, okay, and then mark a task as completed, and then of course you can delete a task. Okay, so this is the specification of service layer, and actually you will see today that we leverage the TODO to validate our specs. Pretty cool if you want to think about this. This is kind of the data model, if you will, right? The user ID, which is very simple, and then you have item ID, and then whether it's completed or not, and then title, and then an offset, which basically lets you order and reorder. One of the things about Cassandra is it has a partitioning key, and then what is referred to as a cluster key. So a partition key is used to go find a partition, and then within the partition you can order it based on the item ID. Okay, so pretty cool. So our partition key is the user ID, and then how do we find the different? We find the to-dos, we do the create to-do, we do the delete to-do, update to-do, and so on. All pretty straightforward. They map to CRUD-based operations, which is the create, read, update, delete. Okay, and we have made a slight modification here. We use the user ID in the URL. Okay, and of course, there is always different versions. So we are using V1. If you want to move to V2, you can do that, and that's a recommended REST practice. And then, of course, you use the user ID and then to-dos, and we'll see all of this in action today. Okay. So there are a number of different frameworks that you can start using today, and I'll bring that up in a second. Okay, and then there are a number of backends as well. So we'll take a look at all this in a second. Okay. And essentially what this lets you do is called the REST APIs. But really what we are interested is in Quarkus, right? And what we are doing here is essentially kind of the MVC model, right? Where you have a model front end, and then the back end is built on Quarkus and REST, that you're going to see today. And then of course the back end is on Astra. I'm trying to think. There is one example of where it's on Cassandra, and we'll see that as well today. Okay, so this is very loosely the architecture. Might not be like a microservice, but if you think about this, these are you will see that these services are calling each other, and we leverage some services that we did not build, and so on. Okay, all right. So before I get to resources, let me jump into live code. All right. Okay, hopefully you can see this. So let me start off with...
All good. We can see your screen.
Perfect. So I'm going to start with my building the application, right? So I'm going to build the... let's see. The screen is going off the... Okay, that's good. All right. So I'm going to start my Quarkus application. Let me start this off, and then we can go back and look at the code. Okay. Okay, you'll see that it's starting off. I mean, this is very familiar to those of you who used this before, right? And let me show you what's going on here. Okay, it did create a table, as you can see, and so I'm going to stay on this page. And what I'm going to do is I'm just going to look at to-do items. Okay, we do a clear, and this is the SQL console that's available as with the database as a service. You can do a whole bunch of things here. I'm looking at this database called Workshops, and then what I'm doing is I'm using a container called native Java. I'm using a key space called native Java, and this will all map. It'll come together in a moment. Okay, so let's look at what are the to-do items. Okay, and you'll see here these are the to-do items, right? Now what I'm going to do is I'm going to basically bring up the client that goes with it. Okay, so to leverage that, what I'm doing, and I'm kind of doing this a little bit backwards, but I'll get to that in a second. Okay, I will use the client. Okay, so let's try this. And let's call it Quarkus. Okay, because this is the user ID. Okay. So I am demoing Quarkus. Hope it works. Doesn't matter. If it does not, it's my fault. Okay. So if I go back and look, hopefully these should have been added to So you'll see here, right? I got 3 of these. But one of the cool things about this is what did I did was I did not build a GUI myself. I just leveraged the todobackend.com. So to do that, let's go take a look at todobackend.com. Okay. There are a whole bunch of to-do backends here. Okay, so just for kicks, let's look at Quarkus. Okay, and you will see there is a few. Okay, you can run the specs, you can view the code, you can look at the example implementation. Let's look at the example implementation. Okay, so here's an example. I believe this is running on Heroku. You can see here Heroku, right? This is Heroku. Okay. And kind of works the same way. So this kind of gives you an idea of how these, you can kind of connect these together. But one of the cool things here is I can run the specs. Okay, so let me run the specs, and you'll see what this means in a second. Okay, so basically what this is doing is it's running the same specs and getting an idea and validating the REST API, right? So it's validating this so that any service can call each other and your microservices approach is validated. Okay, so now what I'm going to do is I'm going to choose a different server to target. Okay, and to pick a different server. Okay, I'm going to go back, grab this URL which is running on localhost, right? And see if I can plug this in here. Okay, where was this? Right here. Okay, and hopefully it will validate, right? So if I put it in here, let me see if it works. All right. So now what it's running is it's essentially validating the specs from my local host. Very cool, right? I mean, of course, what I could have done is I could have just said, I think /q/dev, right? What did I do here? Quarkus to do. Oh, just this. Okay, and what I can do is, I can look at my config, and this is exactly what Quarkus does, which is really cool. It gives me a lot of config information and so on and so forth, right? You can take a look at all this and kind of get an idea. Some of the things that I like myself. Let's see. Let's go through and look at Cassandra. Right, and there is the youth. See, I'm using a password, which is a token-based authentication. So here I'm using a token authentication, and I can plug that in. And in a very short while, we are going to see how we can do a container and so on and so forth. Okay. I think I explained most of what I wanted to do, but let me go to the next step, which is I'm going to get rid of this. Okay. Very cool, right? I just get rid of this. Q is good enough, right? And I'm not showing you the hot reloading part, but you can do all that. It's really a Quarkus thing, right? Now what I'm going to do is I'm going to run Cassandra, okay? And to run this, hopefully, many of you used Kubernetes, and let me show you what's going on here. I'm running it on an EKS cluster, as you can see here, okay? And basically it's on US East 2, right? And what I'll do is I'll just show you what's running here. If we get pods, right? We'll give you the pods. Okay, and you can see here there is, I was talking to you about the CAS operator, and we have the Stargate. Stargate is our front end, and basically it unifies a number of different APIs. Okay, but if you don't want to know too much about this, it doesn't matter. What we're going to do is we're going to show how we can access the same, again, microservices different shapes and forms, right? So at this point, what we're going to do is we're going to access Cassandra, um, the Cassandra cluster. Okay. So to be able to access the Cassandra cluster, I need to be able to do a simple port forward. If I don't want to do a port forward, I can access it on the load balancer. But I'm just going to leverage whatever is there. So let's see if it works. Okay, so that's good. So now what I'm going to do is I'm going to run the same dev, but with a different profile. Okay. And this is the Cassandra. And again, I'm skipping tests. I know Quarkus is really cool for testing, but just for the interest of this demo, I'm going to skip the tests. Okay. Hopefully you should see the connection here coming up in a little bit. So now what it's doing is it's connecting to the local table. Okay. To the table which is on the Cassandra cluster. Okay. So this is a good sign when it says handling the connection. And what I'll do is I'll connect to this using SQL. Okay. So I'm connecting, I'm providing the username and the password, and I'm good to go. Okay. So now what I can do is, let me see if clear works here. Okay, that's good. Okay, and same thing again. Select star from to-do items. Hopefully this is going to work. Okay, so use native Java because that's the key space I'm going to be using, right? And then select star from to-do items. Okay. So now it's a completely different data, right? And if I do the same thing, which is, let's see, go back to my to-do backend. No, not this one. But let's say go back to here, okay, and I'm running the same example, right? Now let's not do Quarkus. Let me do something else, like data stats or something, right? So that's the user I'm interested in now, okay? And run this, and again, I'll make it brief, 1, 2, 3, right? And now if I go back and check my SQL, you should be able to see that, okay? So select star from to-do items where user is equal to, already forgot what I said. User is equal to data stacks. Okay. I just wanted to make sure that. Okay. What did I do wrong here? Oh, where select star from to-do items. I think it's username, it's user ID. Okay, so these were the ones that we just added. Okay, so I can again go back, and instead of client, if I just do a specs, it will validate the specs. Okay, very cool, right? So that's validating, running it on a Cassandra cluster that we just saw a moment ago. Okay, so let me get out of this. Let me kill the port forward, and we're not done yet because again, microservices are in different shapes and forms. Okay, so let me get out of this. Okay, I'm going to build the Docker um, and push it. Okay, so let me do this. And to do this, I leverage something called as Jibe. I probably should have shown it when I did the QDev, but essentially Jibe is really cool. Again, great for the inner loop. What it does is it picks up the credentials from docker.json, as you can see here, does a whole bunch of stuff, and pushes it to my to my Docker public registry. Okay. But how do I run this? Again, pretty straightforward, right? All that I do is I Docker run. And same thing, right? I'm running the Docker image, and I'm good to go. So let's see if this works. Okay. So again, different flavors of this, and hopefully it should be running soon. Okay, and all that I did was leverage again, the part where I used the different profiles and was able to connect to the Astra database. Okay. So it does a whole bunch of stuff, and hopefully I will be good to go in a moment. All right. So again, if I go back to 9393, it should be working, and I can validate this. You've seen the drill by now, right? Pretty straightforward. All that I do is go back again, and I'm just going to validate the specs this time. And maybe I'll use a new one again, or just use the old one. Let's see what happens. So it's a little bit slower, but it still works. Okay. And again, if I go back to client, I can kind of take a look at this, and I can validate this. Okay. So I think I've beaten this to death. One last part that I want to show, which is, or actually two parts. One is the running this on containers, right? And to do that, what I'll do is I'll just bring you briefly into IntelliJ and show you what's been generated. This is the code itself, and I'll point you to the code later. But no surprise here. I'm using a REST controller. I'm using a startup, and then this is the Cassandra service, which basically uses the SQL
Rex,
system.
sorry to interrupt. The font size is a bit small.
Okay, let me increase the font size if I can. Okay. Let me see.
Or you can enter like the presentation mode.
Yeah, that's a good idea. Yeah, thank you.
Appearance?
Right.
View appearance?
View appearance presentation. Okay. A little bit better, or yeah, that's much better. Okay. Mm-hmm. Thank you. Appreciate that. So it kind of walks you through all of this. But what I wanted to show here, let me go back and show you the. I'll go back to exit the presentation mode. Okay, and essentially show this Kubernetes YAML, which is automatically generated for me because of Jibe. And you can see here, it's generated load balancer. It did the container, rags and Cassandra, on different namespace, docker.io, rags and Cassandra. I can use quay.io if I want, and so on, and then set up port 9393. And essentially, you can install this. Okay. So let me go ahead and try that. Okay, so to do that, what I'm going to do is I'm going to install it. I have installed it on the Cassandra cluster. I definitely can, but I'll install it on my Docker desktop. Okay, and this is going to be a little bit slower, but it's fine. Okay, and what I can do here is essentially install it. And to install that, all that I'm going to do is I'm going to apply the manifest, right, that got generated. So kubectl will apply, and run this, right? And you can see here there are two services, the service and the deployment that's being created. So what I'm going to do at this point is, let's look at the kubectl get all. This takes a little bit of time to start up. Of course, if I used a native image, the startup might be a lot faster. But you can see here it's container creating. Okay, and what I'll do at this point is probably run the native image, because that takes a little bit of time, and see if that works as well. And how do I do this? Pretty straightforward, right? Clean the package, and then actually let me not do a clean. Let me just do a package, just to make, and then we'll go from there. Okay. So that's the last part. This is going to take a while, but let me go back and see if my Kubernetes image is running, right? And to check this, actually, I've set it up on 80. Okay, so let's see if this works. Not yet. Okay, this probably takes a little bit of time. Okay, and I'm let's see if this works. Okay, so it's still taking a little bit of time. Give it a little bit. Let me see if the client is working. see if we go back to specs and try something. Okay, still not up. Not quite sure what's going on there. Let me go back to my. I had some issues here. Oh, that's the Graal VM. That's fine because what it's doing, it's negotiating the SSL, and it's going to take some time. But let me look at what's happening with my Kubernetes. Okay, like I said before, not everything is going to work, right? This could be fun. So let's see. Maybe my Docker desktop died. Okay.
Yeah,
All right.
Rex. Yeah, we know
Let's,
that the native image takes a bit of time.
it does. Yeah, but I'm looking at Cube. This should work. In the meantime. So I'm just letting it go in the other window. Okay, there is Docker desktop. That's good. But do the try get parts. Okay. So let's not worry too much about what's. Yeah. So I've had this problem occasionally before where the Docker desktop dies, but believe me, it does work. Okay. So let's see what happened here. It's almost there. So this is the last part, which is to be able to run the native image. Okay. And if this runs, we will call it quits. Okay. So to run this is really cool, and you will see, it starts up really quickly. Okay. And Astra demo runner, right? So this is the one that just got generated, and I'm going to run this. Actually, let me make sure that this is the latest one, right? And you can see here, it just got generated like a minute ago, and I'm going to run this, right? And it's running, and hopefully it should come back and ask me to allow network. And you can see it was a lot faster, visibly, right? And what I'm going to do is hope that it's probably the last one that I'm going to show. Okay, and I'm going to run this. Now it's still 9393, right? So I'm going to make it 9393 and run data new to-dos. Let's see if this works. Okay, keeping my fingers crossed. and there you go, right? It validated. This was a native image. I mean, how cool is that, right? Everything was built, and essentially it was able to validate. If I go to the client, I am leveraging again, what's available out there, right? You can see, it generated this blah blah blah, A, B, C, whatever, right? And then if I go back and get this through my SQL console, you should be able to see all this. Okay. So you can see here data new, blah blah blah, A, B, C, D, D, whatever. Okay. So hopefully that kind of gave you an idea of how to use these microservices, leverage these, and so on. So I have a few more slides to get through, and with that, so we do this workshops every week. So please, feel free to attend anytime. These are all free. I always say that we are living in a golden age of developers. A lot of resources, lot of help. Time to first hello world is pretty straightforward these days. Otherwise the platform is not relevant at all, right? Quarkus, Cassandra, a lot of the other platforms also are making it a point to make it easy for developers to use. You can earn a lot of badges, different kind of badges, all looking pretty cool. We have quite a few people who have more than 20 of these badges. All that you need to do to earn those badges, you have to do a homework and we actually grade them, and you can earn those badges. Okay. We are also doing a hackathon that's going on right now, and it goes till May. We're calling it the side hustles because we realize that many of you are busy, but you can make this a side hustle. One thing you can learn. Two is you can even make some money. Okay, I think the maximum price is something like 5,000. Okay, don't quote me on that, but definitely there is more than that in prices. Try out Cassandra and Quarkus. I had a workshop. I have a link at the very end of that, which kind of walks through how you can do debugging in Quarkus. Especially if you have not used it before, and again uses the Cassandra backend. There are other examples as well that you can try out. Some of these might be a little bit outdated, but you can kind of adapt it to your own scenario. You can check out Cassandra. We are actually coming up with an operator which makes it very easy to be able to install it on multiple clusters. One of the cool things, like I said about Cassandra, is that it was good for horizontal scaling and to be able to do disaster recovery and all that. It comes pretty much right out of the box and kind of fits really well with that. With that said, thank you very much. And again, hope to see you some part of the world sometime. Edson, I don't know if we have time for questions.
Yeah, I think we're out of time for questions today, but I would like to I really appreciate your session. I'd like to thank you, Rags, for coming here and talking about Quarkus and Cassandra, and I hope to see you in another DevNation session. Who knows?
Thank you all. Bye.
Thank you. Take care.